Hello, geometry students. Here are your notes for section 3-4, perpendicular lines. Missy McCarthy, Oak Miss High School math instructor. In this section, what we'll be doing is proving and applying theorems about perpendicular lines. In the first half of the section, the chapter, we dedicated a great deal of our time to parallel lines. Now we're moving on to perpendicular. So the very first definition that you need to know in this particular section is that of a perpendicular bisector. So a perpendicular bisector of a segment is a line that is perpendicular to the segment and intersects the segment at its midpoint. So if we were to draw our segment here, I'm going to call this segment AB. And then if I were to measure and find the midpoint, I'm going to mark the midpoint here, and that's going to be at M. And to indicate that it's a midpoint, I need to put my tick marks on either side to show that AM is congruent to MB. And then if I have a line, let's call this line line L, that is perpendicular to the segment, then we can say that line L is the perpendicular bisector. It meets the two qualifications. It's perpendicular to the segment by our right angle mark here, and it intersects the segment at its midpoint, point M, and we have our lines indicating that it is indeed the midpoint. Now it says the shortest segment from a point to a line is the perpendicular to that line. So if we had a point here, and let's call this point C, and we wanted to find the distance from C to segment AB. We could go from C to AB this way, we could go here, we could go here, here, but what this says is the shortest distance, or the shortest segment from point C to a line AB, or segment AB, is the perpendicular to that line. So every single one of these that I'm currently erasing will be longer. The shortest segment is this one right here, the perpendiculars. And that's why we call that the distance from a point to a line. It's the length of the perpendicular segment from that point to the line. So this is the perpendicular, and this is also the distance from point C to segment AB. So it says name the shortest segment from point A to line BC. So we have line BC here and point A here, and we have lots of segments, but the shortest one is going to be the one that is perpendicular. So the name of the shortest segment would be segment AP. Now it says write and solve an inequality for X. So if this is the shortest segment here, this is another segment, and we have X here, we know that segment AC has to be longer than segment AP, because AP is the shortest. So we could say X minus 8 has to be greater than 12, and then add 8 to both sides to get that X has to be greater than 20. So that's what we did. We wrote and solved an inequality for X, because the shortest distance from a point to a line is the perpendicular segment. Okay, now there are three theorems about perpendiculars that we're going to look at. This first theorem says, Theorem 341, it doesn't have a name. It says if two intersecting lines form a linear pair of congruent angles. So we have two lines here that are intersecting. They form a linear pair of congruent angles. The congruent angle marks are here. Then the lines are perpendicular. Two intersecting lines form a linear pair of congruent angles. Then that means that the two lines are perpendicular. There's a shorthand way of writing it, and that is right here. Two intersecting lines form a linear pair of congruent angles, then it's safe to imply that the lines are perpendicular. So that's one of the theorems. The second theorem that we're going to be looking at does have a name. It's called the perpendicular transversal theorem. It says, in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So we have here that lines N and P are parallel because of the markings here and here. And we know that this transversal Q is perpendicular to N. So this theorem says it's safe to say that Q is also perpendicular to P. Now that's not something that's given. That's what we can conclude. And that's the perpendicular transversal theorem. And then the last theorem about perpendicular lines says, if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So this is similar to the other, but they're not telling us that these lines are parallel. We just have two lines, and the transversal is perpendicular to both of them. Therefore, it's safe to conclude that those two lines are parallel. Two lines perpendicular to the same line implies two lines are parallel. That's the shorthand way of writing it right here. Okay, so let's practice proving the perpendicular transversal theorem. So we have our diagram here, and we have what we're given, and we're going to see if we can't go through a series of statements and reasons to actually prove this. So we know that line BC is parallel to AD. I'm sorry, that line BC is parallel to DE. That's one thing that we're given. And we know that AB is perpendicular to BC. So we can't use the perpendicular transversal theorem. We have to actually prove it. So I'm going to write what we're given. We're given that line BC is parallel to line DE. That's given. If they're parallel, then, using what we learned previously in the chapter, that means that angle ABC is congruent to angle BDE. That's by the corresponding angles postulate. So I have that those two guys are definitely congruent to one another. And then the next thing they tell me is that line AB is perpendicular to line BC. That was given. So then that means that the measure of angle ABC equals 90 degrees, is a right angle. That's the definition of perpendicular. Okay, so if they're congruent and ABC is equal to 90, we can say also that the measure of angle ABC equals the measure of angle BDE, and that's by definition of congruence. Congruent angles. So if they're congruent, then that means the measure of angle BDE is also equal to 90. And that's by the definition, or that's by the substitution property. So if angle BDE is also 90 degrees, then that means that line AB is also perpendicular to line DE by definition of perpendicular. And so we have just proven the perpendicular transversal theorem. Okay, here's our final example, I believe, and we're going to do one more thing to practice with proofs. This one you're given the statements and we're going to put the reasons in. Okay, so we know that R is parallel to S. I'm going to put the little markings on here to remind me that R is parallel to S. And we also know that angle 1 is congruent to angle 2. And we've got to prove that R is perpendicular to T. So R is parallel to S, and angle 1 is congruent to angle 2. So I'm going to put that those are congruent. So that's going to be given. Then I also know that angle 2 is congruent to angle 3, and that is by the corresponding angles postulate. Because we have parallel lines cut by a transversal, so the corresponding angles are congruent. 1 is congruent to 3. How do we know that? Well, we know that by the transitive property. As 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3 by the transitive property. So now we have 1 is congruent to 3. So we can say that line R is perpendicular line T because of the new perpendicular postulate that we learned, that two intersecting lines form a linear pair of congruent angles. Then the lines are perpendicular. And that's what we have. We have two intersecting lines forming a linear pair with 1 and 3, and 1 and 3 are congruent. So therefore the lines must be perpendicular. Okay, be sure to rewatch any parts of the video for full understanding of perpendicular lines and the theorems that are associated with them. Start making some flashcards to help with your recall for the important definitions, postulates, theorems, and properties. If you're watching on YouTube, again, feel free to type questions in the comment section and I will get to them and answer them as quickly as possible. Lastly, instead of doing a lesson quiz, I want you to go into your Google Doc, fix up sections 1.1, 2.1, and 3.1 according to the feedback that I've given you, and also add the important concepts now for sections 1.2, 2.2, and 3.2. You can switch it up. If you did chapter 1 before, you can do chapter 2 next, and so on and so forth, or you can keep it the same as before. I think it might be a better idea to switch it up so that you're covering more concepts as an individual, but it may be simpler for the groups to keep it the same. But you don't want to be all the way at the end and know chapter 1 really well and not know any of the other chapters. Also, I want you guys to work on cohesion between the sections, making sure we're using similar fonts, making sure we're adding diagrams, we're formatting in the same way, and so on. Okay, so go into your Google Doc, and I want you to add 1.2, 2.2, and 3.2 after you've fixed up 1.1, 2.1, and 3.1. Let's make this due by Friday. See you guys later.